My name is Steven Jones, a physicist. I received my PhD in physics from Vanderbilt University in 1978, so I've been at this for over 30 years, studying various subjects. I like to study those things that have an impact on society wherever I can, such as fusion energy. That's been my bread and butter for many years. In fact, began that probably in about 1979, my research into fusion, various kinds of fusion, starting with hot fusion, then muon catalyzed fusion, metal catalyzed fusion. And I'm still very interested in alternative energy methods. I've published papers in Scientific American, which was a paper about muon catalyzed fusion. I've published papers in Nature, a British publication, and several papers there. I published in Physical Review Letters, and so I have some awareness of the importance of peer review, and I can say in all honesty that my first paper on 9/11 research met with considerable flack, and it was reviewed, peer-reviewed very heavily actually, and before publication, it was thoroughly peer-reviewed. One of those peer reviews happened when I spoke at the Utah Academy of Sciences, Arts, and Letters in that'd be April of 2007. I have published over 50 peer-reviewed papers in my career. Now, with regard to 9/11 research, this began for me in the spring of 2005 when I heard a speaker saying that, based on her analysis, she made this rather bold statement to a large group of people. She was speaking about something entirely different, but she paused and she said, "Now, if you think that those World Trade Center towers came down just because they were hit by airplanes, you have some major surprises ahead of you." And this huge audience, it must have been 700 people, burst out into applause. I was one of those that was not applauding because I didn't know what she was talking about. So, but the next day or two, I got on the internet and plunged into my study of World Trade Center 7 and the anomalous events of 9/11. Dr. Ferrer has covered a number of things. I want to emphasize a few other points, and these are our study of both the spheres, but particularly the active thermitic red material that we discovered in the dust from 9/11. This is discussed in our paper in the Open Chemical Physics Journal, published in April of 2009. And I would encourage a careful reading of this paper. We put a lot of work into this peer-reviewed publication. I'd like to talk first of all about the provenience or chain of custody for the samples that we received. I'd like to mention that in this paper we studied 4 samples in detail, 4 separately connected dust samples. I received samples from several people, and Dr. Ferrer received samples directly from at least 2 of these collectors. I think three of the collectors. Okay, separately. So it's not like someone could go to these collectors. I've heard this argument that somehow perhaps someone seeded these samples with nano-thermite. Well, you know, folks, it's very difficult to create this stuff. I don't know how to make this stuff. Kevin Ryan, chemist, is trying to make this nano-thermite, but it's not easy. We do have descriptions from the Livermore National Laboratory in particular of how they fabricated this material, but to fabricate it is not so easy. First of all, the iron oxide grains are uniform and approximately 100 nanometers across. That's very tiny, much smaller than a human hair. The aluminum occurs in plates that are about 40 nanometers across. I have no idea how to make those. I mean, this is a high-tech material, and it's embedded in a carbon-rich matrix with... okay, so I've also heard the argument that perhaps the falling buildings just generated this nano-thermite. Well, no. Okay, first, as an experimental physicist, I actually took some dust from buildings that were destroyed by controlled demolition. There's a bank in Salt Lake City and a hotel in Las Vegas. And so people collected the dust and sent those into our laboratory. We looked in the dust, and there were, believe it or not, no red-gray chips. Okay, it relates to the second law of thermodynamics, but I probably won't go into that detailed argument. I'll just say, if you imagine these chips which are highly active, it's like a match head. And say you have the ingredients of a match head in a building. Okay, sulfur, carbon, whatever else they put in the match head, and then the thing falls. And you find little match head ingredients from a building falling? I mean, no. It has to do with, under chaotic circumstances, things go downhill, not uphill, okay? It's the second law of thermodynamics. I have to talk to students about this, excuse my impatience, but second law of thermodynamics is, has to do with increasing entropy and disorder, not order. These red-gray materials have very orderly sheets containing aluminum, these platelets, and these grains containing the iron oxide, again, are of uniform size, very orderly. And furthermore, if it's from a collapsing building, where does all this carbon come from for the matrix? It's just mind-boggling. A colleague of mine asked various nanoscientists if they thought that a falling building could create this material, which I thought was great because he got them to consider our study. But 100% of these nanoscientists contacted said no. There's no way that a falling building can create this sophisticated material that we report in our paper. Now, back to the chain of custody. So it's not just from collapsing buildings. It did come from the dust of the World Trade Center, and as I said, samples were sent separately to Dr. Fair and to myself. These samples all show the same red-gray material. A separate sample was sent to a scientist, Mark Basil, and working in New England, and he also sees the same active red-gray thermitic material. I have to say one thing while I'm discussing the efforts by Mark Basil. He was the first one to ignite a red-gray chip and observe the spheres, the tiny iron-rich spheres in the residue after the red-gray chip is ignited. And so I think it's important to give him credit for that observation. Then we looked in our residues from the red-gray chips, and we also found these spheres. But I'd just like to say that that was found independently and first by Mark Basil. Now, the chain of custody. The earliest collected sample came from Frank D'Alessio. He provided a videotape testimony about how he collected this dust. Frank D'Alessio was in Manhattan the morning of 9/11. He was present when the towers collapsed. He was over by the Brooklyn Bridge, the Manhattan side. And he reported that the dust was falling and it was collecting on the ground, and he picked up a sample and he felt this was significant, and so he saved it. He put it in his pocket actually and went over to a friend of his by the name of Tom Breidenbach, and they decided to save this souvenir of the World Trade Center tragedy. And both of their testimonies about this sample are recorded. Frank D'Alessio collected the sample about 10 minutes after the collapse of the second tower, the North Tower. He saw the tower fall, he saw the dust being generated, and he swept up a handful of the dust from a rail on the pedestrian walkway near the end of the Brooklyn Bridge on the Manhattan side. And then this sample was saved, and a portion of this was sent to me. I asked all the collectors as they sent me a portion to retain a portion of the World Trade Center dust, so that when we have this investigation, which we are demanding, that there will be samples in the hands of the actual collectors that the investigators then can obtain, and they will find the red-gray chips in this material because we've already sampled the other portion. So this sample was collected 10 minutes after the collapse of the tower, long before any cleanup operations began, and therefore it is impossible for cleanup or steel cutting operations at ground zero to have contaminated these samples. They were collected long before these cleanup operations began. Similarly, the second sample comes from Mr. Stephen White of New York City. It was collected on the morning of September 12th, the day after. And again, this would not be contaminated by cleanup operations, which began later. He found a layer of dust about an inch thick on a stack of folded laundry near a window that had been left open in his apartment. Clearly the open window had allowed an amount of dust to enter the room and cover the laundry. He saved some of this dust again. And on February 2nd of 2008, he sent a sample to me for analysis. The third sample was collected from an apartment building on 16 Hudson Street by Mr. Jody Intermont in the afternoon, about 2 p.m. on the 12th of September. 2 small samples of this dust were simultaneously sent to Dr. Jones, myself, and Kevin Ryan in 2008 on February 2nd. And Mr. Intermont signed an affidavit accompanying each of these samples, verifying that he had personally collected the sample, which was now split, and he gives permission to use his name in conjunction with these samples. So the chain of custody was direct from the collector to the scientist, and a separate sample went to Kevin Ryan. Let me read the signed affidavit by Mr. Intermont. This dust, which came from the collapsed World Trade Center towers, was collected from my loft at the corner of Reed Street and Hudson Street on September 12th, 2001. So that was our third sample. The fourth sample was collected by Jeanette McKinley in her 4th floor apartment on Cedar Street and Liberty Street in New York City. This is a very interesting sample because Jeanette's apartment was just across the street from the World Trade Center plaza. And as the South Tower collapsed, she was in her apartment. And the force of the collapse and the debris blowing from it across the street broke her windows of her apartment, and the dust flowed in. We actually have photographs of the interior of Jeanette McKinley's apartment with this layer of dust everywhere. Now this is a very important sample because it was collected immediately as the tower was falling, you see. Yeah, I should mention that Jeanette McKinley, like so many others who breathed in this dust, this toxic World Trade Center dust, she has become very sick, extremely ill, and many have died and from this, and this has been attributed to the toxicity of this dust, which, according to scientists, had an alkalinity equivalent to that of liquid Drano. There's also asbestos in the dust and other nasty things like mercury. So let me just talk a little bit about the toxicity of the dust, having discussed now the chain of custody for each of these samples, which is clean, and we'd be glad to testify in court about these samples and the independence of them, the fact that they were not and really could not have been seeded. I rather resent that accusation, as if I knew how to make this stuff to begin with, or would have a proclivity to seed scientific samples. No, we're behaving as scientists and proceeding in a scientific manner as we study this dust. With regard to the World Trade Center dust sample collected by Jeanette McKinley, she told me that she had a sense that this dust could be usable in an art project of hers, a display. She is an artist, and as my first report came out with regard to the World Trade Center destruction and the anomalies and my questions about the official story, Jeanette read that report and she contacted me and said that she had this sample of the dust, would I'd like to look at it. And of course I said I would. I actually traveled to California to visit Jeanette McKinley, and with other scientists present, I collected a sample of the World Trade Center dust. Subsequently, dust samples from Jeanette McKinley were sent directly to Dr. Ferrer and to Kevin Ryan. And all of us have seen these red-gray chips in this World Trade Center dust. So the chain of custody is clean, and the science is very sound, I believe, and has been published and not refuted. So we feel we're on very solid ground with these studies. I don't know that I need to repeat what Dr. Ferrer has described very adequately and very well. So I would like to emphasize certain conclusions that we determined from our study of the World Trade Center dust and this red material that Dr. Ferrer has discussed so very adequately. I would like to say before proceeding that Dr. Ferrer was a key in analyzing this red-gray material, and his expertise with both the scanning electron microscope and the transmission electron microscope proved to be invaluable in this study. Okay, so significant conclusions regarding this red-gray material that we found in the dust. The primary elements in the red material are aluminum, iron oxide, as well as silicon and carbon. I'd like to say that the silicon first confused me when I saw that in this red material, because it's not needed in thermite. In thermite, all you need is fuel, aluminum, and an oxide, a metal oxide such as iron oxide, so that the oxygen goes from the iron oxide to the aluminum with the release of enormous amount of energy. And this also results in a production of molten iron. Now, and some of that would be, as you have this molten iron being formed explosively, will form droplets in the air. And we do see many iron-rich droplets, both in the World Trade Center dust and in the residue, the ash from burning these red-gray chips. The question about the silicon, why is that present? I think it was Kevin Ryan that pointed out to me that as nano-thermite is being made, this is now thermite with very tiny constituents of iron oxide and aluminum. So when nano-thermite is being made, typically silicon is involved in the mix. It becomes part of the matrix when the sol gel method is used, for example, which is described in detail in the literature from the defense laboratories such as Livermore. It's these guys at the defense laboratories are very excited about nano-thermite because of its applications for explosives and so on. They do say that all the applications they will not go into. I remember at least one of the National Lab papers discussing the fact that nano-thermite can be used for demolition, controlled demolition. So I thought that was interesting, at least for igniting the standard explosives such as CH4. The iron oxide appears in faceted grains, approximately 100 nanometers across. as Dr. Ferrer described. The aluminum appears in thin platelets about 40 nanometers thick. It is the small size of the particles involved in this material that allow us to characterize it as nano-thermite. In ordinary thermite, the particle size is much larger, and hence ordinary thermite is an incendiary. Whereas as the particle size becomes smaller and smaller, it can become explosive. Super thermite is sometimes called. Dr. Ferrer found that the iron and oxygen are in a phase consistent, that is Fe2O3. Dr. Ferrer conducted studies in the differential scanning calorimeter and found that the material ignites, reacts vigorously at a temperature of approximately 430 centigrade, consistent in each sample. This is approximately the temperature at which nanothermite ignited in a study published by Lawrence Livermore National Laboratory. Also, the narrowness of the heat trace, the DSC trace, indicates that a very rapid reaction has occurred, both in the study with no nanothermite and in the study of the red material as found in the World Trade Center dust. We found that the spheroids that are rich in iron produced by the DSC test, that is, by the ignition of the red material in the DSC, these have a signature of that is rich in iron with not enough oxygen to make even FeO. So that indicates to us that the iron has been reduced, which again is a signature for the thermite reaction. So the formation of the spheres, which implies a very high temperature, over 1400 centigrade, and the reduction of the iron oxide to an iron-rich phase indicates that a thermitic reaction has occurred. And therefore, we are able to call this a material an active thermitic material, both from our DSC studies and from the results from the electron microscopes. Let's not forget that this red material contains also a significant amount of carbon. And the formulation of nanothermite as described by National Laboratory publications also implies the presence of carbon, very typically. The organic is used with nanothermite in order to produce gas. That is a very high pressure gas that makes the nanothermite an explosive. And so all these results are consistent with the presence of a pyrotechnic or explosive in the World Trade Center dust in large quantities that really should not be present in an office building in downtown New York City. Okay, so we need some investigation that will take the blinders off and say, we're not just going to look at fires. We will consider the possibility of explosives, and we will look for explosive residues, as we have done on our own initiative in the World Trade Center dust. And on the steel that Dr. Ferrer mentioned, we need an investigation that will have the power to subpoena these samples collected by Professor Barnett, and then we'll look at the residues that you can see in photographs of this Swiss cheese steel from the World Trade Center 7 and from the towers, and be able to determine if this residue has aluminum entrained in it, as we expect from the use of thermite. This is the residue on the surface now, this grayish residue that you can see. I predict that aluminum will be found entrained in that residue on the surface. Or some other, well, that's, I mean, thermite can be made from other combinations, but one would expect aluminum as the most readily available fuel for this type of a high energy reaction that would result in the sulfidation and even evaporation of steel, because the temperatures can be reached by thermite. In conclusion, I strongly support an investigation, a thorough and fully funded investigation of the events and people involved in 9/11. Allow people to come forward and testify of what they have heard about 9/11 from various sources. We need this investigation. Right now there is, in effect, a dark cloud hanging over America because of these unanswered questions. It would be better to face this head on and allow a thorough investigation and perform this investigation in such a way as to get at some answers. And so we need this investigation, and I think that's all I have to say about that today.